So a centroid is the intersection of three medians. So basically in the diagram here you have BM is drawn from the vertex to the midpoint up the opposite side. That's called the median. If you have the intersection of three medians, point P here would be a centroid. And there's two rules that are that come about with having a centroid. So the first one is that the centroid is 2/3 of the distance from the vertex to the midpoint. So from B to P is 2/3 of this entire median. Or you could say that then PM would be 1/3 of the distance of the entire median. So in the problem here it says that BM, so this entire median, is a length, that's supposed to be my curvy brackets, of 36. We have to find BP. So this longer piece here is going to be 2/3 of the entire median, which if you don't know how to do this, you would just put it in the calculator. But really what you're doing is 36 divided by 3, which is 12, times 2, which is 24. So BP is 24. And then PM is that shorter distance. So PM would be 1/3 of the entire median, which again, it told you was 36. And you get 12. The other rule that comes about with a centroid is that it divides the median into a 2-to-1 ratio, which actually you can see just by looking at the results in this first rule. See how 24 to 12 breaks down to a 2-to-1 ratio? So in the next question, it says that CP, so from C to P, let me kind of highlight it here. From C, oh, that was way too thick, way too thick. There we go. Okay, so CP is 22. So this is 22, and we want to find the distance from just P to N. So since the centroid divides the median in a 2-to-1 ratio, if CP is 22, then PN has to be half of that, which is 11. Okay. And next, let me get rid of this. The next part says that PL equals 4. So from P to L, that distance is 4. You can see this is the shorter part of it. And we want to find the distance from AP. Okay, so again, it's going to be a 2-to-1 ratio. So if the smaller piece is 4, you would just multiply it by 2 to get the longer piece, which is 8.